Welcome to the deep dive. Today, we're setting the scene somewhere pretty intense. Think heavy industry, deep inside places where the air itself can be a hazard and the clock is absolutely unforgiving.
Yeah, imagine being inside, say, a huge oil storage tank or maybe a chemical processing unit, some confined space.
Exactly. And you're up against a tight shutdown deadline. Every single minute you lose, and there isn't just time, it's potentially thousands, maybe tens of thousands of dollars lost. Or worse.
Or much worse, yeah. Safety failure. Catastrophic.
So, the gear used in these spots, it just cannot fail. That's what we're digging into today. We're looking at sources about a specific piece of kit, the RamFan EL-55ZDC EX50Li zero downtime package.
Right. And it's more than just a fan, isn't it? It's presented as a whole strategy, really.
That's the angle. We want to understand how it aims to beat downtime, and maybe why this particular setup is getting traction with the folks buying equipment in, oil and gas, manufacturing, utilities, that kind of thing.
Well, it speaks to a shift in thinking, doesn't it? For years, ventilation might have been seen as just basic. A motor, a cord, plug it in.
Yeah, a necessary evil, perhaps?
Kind of. But now it's being treated as absolutely mission critical, like on par with the core processing machinery. The whole idea here is trying to engineer failure out of the equation.
Make downtime the enemy defeated, as one source put it.
Exactly. Obsessing over reliability, making it deploy super fast. That's the philosophy.
That's a big claim. So let's start right there. Why is ventilation such a potential weak spot? Why can't it quit?
Well, it comes down to two things, really. Safety and profit. People first, always. Life over steel, as they say.
And regulators like OSHA make sure of that.
They certainly do. If your ventilation fails in one of these environments, you're not just dealing with discomfort. Instantly, you could be violating safety rules, containment protocols.
The air could become toxic, or maybe explosive.
Precisely. Or temperatures could spike dangerously. The job stops dead. And often, that kind of failure, it's a reportable incident. Paperwork, investigations, the whole 9 yards.
And stopping the job in heavy industry?
Yeah.
The costs spiral immediately, don't they?
Instantly. Massively. So, okay, what's RamFan actually putting in this zero downtime package to tackle all that?
That's the question. What are the core components?
Okay, so the sources detail a few key things. First, you've got the muscle, a high-output 115-volt fan, built to move a lot of air.
Okay, standard enough so far for industrial grade.
Right. But the clever part, the bit that enables this zero downtime idea, is the power system. It comes with four high-capacity lithium-ion batteries.
Oh, that seems like a lot. Why 4? Most portable tools have 1, maybe 2 tops.
Well, it's about anticipating failure, or rather anticipating the need for continuous operation. It's built around redundancy. The system runs off these batteries.
And how are they charged?
They're charged using a 12 to 24-volt DC charger, VDC, volts direct current. That's key.
Why DC? What does that enable?
It means you can charge it directly from a vehicle, a truck, some other piece of heavy equipment out on site. That gives you massive mobility, flexibility, especially for remote jobs.
Okay. So you're not tied to finding a standard AC wall outlet somewhere.
Exactly. And then all of this, the fan, those 4 batteries, the DC charger, it's all integrated into a truck mount system designed for easy in, easy out.
So grab and go, basically.
Pretty much. The idea is the crew can unclip it from the truck and have it running where it needs to be in, well, minutes, not hours spent wrestling with generators and cables.
Okay, that deployment speed is interesting. But let's circle back to that big claim, zero downtime.
Yeah.
That's a unicorn for anyone who manages complex gear. How does the tech actually promise continuous operation?
It's all about that battery setup and a hot swap strategy. Think of it like a pit crew in Formula One.
Okay.
You might need, say, 2 batteries to run the fan at full power, but you have 4 batteries total. 2 are running the fan and the other 2 are sitting there fully charged, or maybe they're on the charger in the truck.
Right, spares.
But more than spares. The system lets a crew member physically pull out a depleted battery and slot in a fresh one while the fan is still running.
No interruption to the airflow at all.
None. The fan doesn't slow down, doesn't stop. The power handover is seamless.
So the weak link, the power cord getting cut, or a generator failing, or a breaker tripping somewhere inconvenient, that's just removed.
That's the core idea, yes. By going battery-centric with this hot swap capability, They eliminate those common external failure points.
Meaning the equipment itself shouldn't be the reason the job stops.
Exactly. The job dictates the stop time or maybe some other safety factor, but not the ventilation gear failing. That's huge for, say, long purging operations or keeping things cool during critical welding or hot work.
And you mentioned the power flexibility, that DC charging.
Yeah.
How critical is that 12 to 24 volt capability compared to just, plugging into the mains?
It's really the difference between being tied to existing infrastructure and having genuine, independent, rapid response capability.
Because out on site, you might not have AC power readily available.
Right. Think remote pipeline work. Or maybe during a planned maintenance shutdown where they've deliberately locked out and tagged out the main power for safety.
Ah, okay. LO procedures.
Exactly. Being able to just charge off the truck's battery means that fan system is always ready, always topped up wherever the truck can get.
Makes sense. The sources mention an AC charging version too.
They do, yeah. An EL55ZDC model. Probably more for facilities that rely on fixed charging points, inside a plant maybe. But for that emergency response mobile crew scenario, the DC charging is the strategic advantage.
Okay, let's shift gears a bit. Think about the safety managers, the people who have to sign off on using this equipment in potentially dangerous places. Reliability is one thing, but intrinsic safety, that's paramount, right?
Absolutely paramount. This gear isn't just for a breezy day. It has to be built for, as the sources say, your worst day.
And the number one requirement there has to be explosion safety.
Has to be. Must be explosion proof. That's a fundamental difference between proper industrial gear and, say, a commercial fan. Everything, the motor housing, the wiring, the battery connections, it's all designed so it cannot create a spark.
A spark that could ignite flammable gases or dust in the air.
Precisely. That's non-negotiable in many of these environments.
And this ties into all those acronyms you see plastered on industrial equipment. ATEX, NFPA, OSHA. What does meeting those actually mean for the crew using the fan?
Okay, quick breakdown. OSHA is the U.S. government body setting the rules for workplace safety, including confined spaces and ventilation standards.
Right, the baseline.
NFPA, the National Fire Protection Association, sets broader standards, often related to fire hazards, but also hazardous environments generally. Think codes and best practices.
Okay.
And ATEX is the European Union directive specifically for equipment used in potentially explosive atmospheres. It's globally recognized, especially in petrochemicals and international manufacturing.
So hitting all three means...
It means the fan is certified across the board, recognized internationally as safe for its intended hazardous locations. It takes a huge liability weight off the company's shoulders.
Got it. Okay, beyond just being safe, what about performance? What kind of tough jobs does this thing need to handle?
Well, the sources talk about its ability to generate high static pressure. That's a key term.
High static pressure, meaning it doesn't just blow hard, but it pushes hard.
Exactly. It means it can effectively push air through things or pull air through things. Think long runs of flexible ducting, maybe 50, 100 feet, snaking through confined spaces like inside a boiler or a tank.
So it can overcome resistance in the ductwork.
Precisely. That's vital if you're, say, clearing out volatile gases from a huge storage tank before welders can go in. Or maybe you need to keep a sensitive piece of equipment, like a big transformer, cool during an outage.
And it can blow air in or pull air out.
Yes, it offers both positive and negative pressure. Blow clean, cool air in for the workers or for cooling equipment. Or set it up for negative pressure to suck contaminated air out and vent it safely away from the work area. That control is crucial.
Okay, so we've got robust tech, top-tier safety compliance, but let's be honest, this kind of package, it's not going to be the cheapest option on the market, is it?
Oh, definitely not. This is premium specialized gear.
So we need to connect that reliability, that performance, back to the person holding the budget, the procurement manager. Why spend significantly more on this system versus, say, buying 2 or 3 cheaper, corded, maybe non-certified fans?
Because you absolutely have to look beyond the initial purchase price. You have to calculate the cost of failure. One source calls buying cheap gear a false economy, and I think that's spot on.
A false economy. Explain that. What happens when that budget fan fails mid-job?
Well, think about the domino effect. First, the job stops. Instantly, you're paying your entire crew, potentially a large, expensive crew, to stand around doing nothing. Huge, unproductive labor cost.
Okay, lost productivity. What else?
If the shutdown drags on, you're looking at massive overtime, OT, just to try and claw back the schedule. Then there are potential fines from OSHA or other regulators if that equipment failure directly led to a safety violation.
Fines, OT. Lost time. It adds up fast.
It adds up incredibly fast. And that's before you even consider the softer costs, like damaged team morale or the absolute worst case scenario, a safety incident leading to injury or litigation. So procurement isn't just buying a fan here.
They're buying, what, uptime?
You
Insurance?
should they're buying guaranteed uptime, essentially. They're buying reduced liability. They're de-risking the entire operation, protecting the much larger investment they've already made in that maintenance window or project.
So smart procurement is really strategic risk management in this context.
Absolutely. And the sources also point out that where you buy matters too. Going through specialized industrial wholesalers, like PE Energy you mentioned in the material, isn't just about getting a good price or fast delivery.
What else do they offer?
Technical consultation. We're talking to people who actually understand the specific compliance needs, the operational realities of your industry. They can help figure out fleet requirements, integration, not just sell you a product code.
That partnership seems crucial, especially with complex stuff like ATEX certification. You need someone who knows what it actually means on the ground.
For sure. The stakes are way too high for just clicking add to cart on the cheapest online option.
Okay, good point. Now let's think bigger than just one unit. Industrial sites often need a coordinated response, not just a single fan. How does this RamFan system handle scaling up? Is it modular?
Yes, very much so. It seems designed as an ecosystem. The idea is that operations can ratchet up their response capability using the base fan unit as a platform.
Ratchet up how? With accessories.
Exactly. By adding specialized modular accessories, you can turn that basic ventilation unit into something much more versatile, going way beyond just moving air.
Okay, can you give us some concrete examples? What kind of accessories are we talking about, and what do they do for the crew? Maybe skip the long model numbers.
Sure. So one example is a rehab mister kit. Think about heat stress, a massive issue in confined spaces or hot environments.
Yeah, dangerous stuff.
This kit essentially clips onto the fan and turns it into a cooling station. It creates a fine mist, helping crews cool down rapidly during breaks, or even providing a quick deacon washdown for minor chemical exposures.
Ah, so it becomes an immediate first aid support tool, not just an air mover. Interesting. What else do you need for different hazard types?
Definitely. There's also a HIX foam generator attachment mentioned. This is more specialized. It's for situations where you're dealing with, say, combustible dusts or maybe materials that are dangerously hot and need suppressing.
So instead of just air, it applies foam.
Precision foam application, yeah.
Yeah.
Think about controlling volatile dust clouds or maybe prepping an area where static discharge is a big worry. It gives the team another layer of control in really hazardous situations.
Turning the fan into almost a localized suppression tool.
Kind of, yeah. A contamination control and suppression assist tool.
Empowering all this extra capability still relies on that core battery system we talked about. How do they manage scaling the power needs if you add more stuff or need longer runtimes?
Good question. It loops back to the battery management. You can scale up the one-time by simply having more of their standard Pro Connect battery packs on hand.
More hot swappable batteries, basically.
Exactly. And to manage charging for a whole fleet of these units, or just to keep those initial 4 batteries cycling efficiently, they offer dual battery chargers. Keeps everything topped up and ready for the next call out or the next shift. Minimizes downtime waiting for charges.
Makes sense. It's all about maintaining that readiness. And the sources also mention even smaller, more portable battery-powered fans in the RamFan line.
They do. An even more portable unit, the EL-55ZDC YD model, is highlighted. It suggests a strategy of having different sizes for different needs, from fixed entries needing massive airflow down to quick mobile responses across a large site.
All running on, presumably, the same battery platform.
That seems to be the implication, yes. Standardizing the power source simplifies logistics, training, maintenance, everything for the safety team, building a consistent safety arsenal.
Okay, this has been a really informative deep dive into this whole zero downtime idea in a critical application. Let's try and wrap this up. What's the key takeaway for you, the listener, from all this?
Well, I think it boils down to this. The specific RamFan package, the EL-55ZDC, is really engineered for situations where compromise just isn't an option.
Right, it's bringing together that certified, explosion-proof safety meeting, the big standards like ATEX, NFPA, OSHA, with that really clever logistical feature, the hot swappable batteries.
Yeah, that battery system is the key differentiator for tackling those really tough, long-duration jobs. Hot work during shutdowns, permit-required confined space entries that can go on for hours or days.
It aims to be the reliable choice when reliability is everything.
And that points to a bigger trend, I think. In modern heavy industry, oil and gas, utilities, complex manufacturing, achieving absolute uptime isn't just a nice to have anymore.
It's what? A competitive necessity.
It's fundamentally your competitive edge. If you can eliminate these traditional weak links in your safety chain, like basic ventilation failing, you directly reduce your operational risk, you reduce your liability, and ultimately you increase your throughput and profitability.
So here's a final thought to leave you with, building on everything we've discussed. If technology like this can reliably take mechanical equipment failure off the table in these critical zones, what does that do to the focus of your safety and operations teams?
That's a great question. If they're spending less time worrying about the fan breaking down or the power cord getting snagged or the generator conking out, where does that mental energy go instead?
Does it shift entirely towards optimizing the process itself, improving team coordination, eliminating the human errors that might still remain? It potentially transforms how you even think about risk management on site.
Definitely something to mull over as you look at your own operations and where the real vulnerabilities lie. Is it the gear or is it something else now?